the 4.5 to 4.8 study guide. So we are finding the measures of all side lengths and angles. So all the side lengths and angle measures. So when we're given two side lengths, we can find a third side length by using Pythagorean theorem, only when we're given two. So we can start by finding, remember, angle A is across from side A. Angle B is opposite side B. And angle C is opposite side C. Remember, side lengths represented by lowercase letters, angle measures represented by uppercase letters. So if we're trying to find A, we can simply use Pythagorean theorem. A squared plus B squared equals C squared. So A squared plus 8 squared equals 14 squared. A squared plus 64 equals 14 squared, which is 196. Subtracting 64 from both sides to isolate A. Get A squared equals 132. So A equals the square root of 132, which we could reduce. Doesn't end up, could reduce it. Typically we round to the nearest tenth though. So for these, we'll round to the nearest tenth. So we enter this in the calculator, square root of 132, and we get that it's 11.5. So A equals 11.5. Now it's technically 11.489 and some change. So when we solve this, we want to make sure that we don't simply, I'd recommend when we're solving for angles B and A, I would use, rather than using this rounded side A, I would use sides B and C, which we know are exact because they were given. So if we want to solve for angle A, because we know C is 90 degrees, so we were to make a chart here. We don't know angles A or B yet. We know side C is 90 degrees, or angle C. We've just found little a to be 11.5. And we were given that B was 8 and side C was 14. So all we have to do is find either angle A or angle B and then use the property that triangles add to 180 to find the other one. So to find angle A here, I'm going to use cosine because I want to use adjacent and hypotenuse, right? Remember, adjacent, opposite, hypotenuse from the perspective of this angle theta. So we have adjacent here, opposite side here, hypotenuse here. So we're using cosine, so we can do adjacent over hypotenuse. So cosine of our angle theta, or you could call it A, since theta is angle A, either one, equals 8 over 14. And to solve for theta or solve for A, we would do the inverse cosine of both sides. So we take the inverse cosine of each side. We enter that in our calculator by hitting second cosine. Second cosine, 8 over 14. We want it in degrees. Make sure we are in degree mode prior to entering this. So theta equals 55.2 degrees. So we know that angle A is 55.2. Then finally, to find angle B, I could have set up a sine ratio, or I could have set up any of the ratios from the perspective of angle B, which would have just switched adjacent and opposite. But instead, the easiest way to do it is simply add together 90 and 55 and subtract that from 180. So when we do this, we get 34.8 degrees. 34.8 degrees for angle B. So that's number one. All right, number two. So I have a given angle and only one side. When this happens, I cannot use Pythagorean theorem, at least not until I have two sides. So we start by solving for either side C or side A. Now we could find angle A as well, knowing that this is a 90-degree angle. So angle A would equal 180 minus 90 plus 24. So that would be 66 degrees. So we know A is 66 degrees, angle A. And now we can simply use trig ratios to solve for side C and side A. So we can say sine of 24 degrees, so angle right here, equals opposite over hypotenuse, 4.2 over C, over side C. Now, this is a little tricky because we have to first get this variable out of the denominator prior to solving for it. So what I'm going to do is multiply both sides by C. That cancel those C's reduced to 1. So I have C times sine 24 equals 4.2. And now I can divide by sine 24 on each side. And that allows me to isolate C. So 4.2 over sine 24 equals C. Enter that into the calculator. Sine of 24 degrees, 4.2 divided by that. We get 10.3. 10.3. So little c is 10.3. Okay, and finally we need to solve for little a. I like using trig because it's more precise than using a rounded answer in a Pythagorean theorem situation. But hypothetically we could do a squared plus b squared equals c squared now that we know c. But I'm going to use trig again. I'm going to say cosine, I'm going to say tangent of 24 equals 4.2 over a. So tangent of 24 equals 4.2 divided by a, opposite over adjacent. Multiply by a on each side to get a out of the denominator. That cancels out our a here. And then divide both sides by tangent 24. So our final answer will be 4.2 divided by tangent 24, which is 9.4 units. So 9.4 is our approximation for side A. And there we go. All right, we have this trickier looking one. We want to find the length of x to the nearest whole number, length x. And this one is simple. This one looks a little tricky at first, but if you break it down into two right triangles, it's actually rather simple as to how we find it. We basically need to find this side, we'll call it A, little a, and this side B, known that we have this leg here. So we can use, to find B, we can set up tangent of 21 degrees, just this angle right here. We're looking at this small right triangle. Tangent 21 equals opposite over adjacent, B over 530. And I can use this to solve for B by multiplying both sides by 530. And B will equal 530 times the tangent of 21, which is 203.45. And I'm not going to round to the nearest whole number yet because I want to first add B and A together. And then to find A, I do the same thing, still tangent, but this time it will be tangent of 46 degrees. Tangent of 46 degrees is equal to A over 530. So multiply both sides by 530. 530 is reduced to 1, so A equals 530 times tangent of 46. And we get 548.83. .83 equals A. Now to find x, we know x equals A plus B based on the segment addition postulate, you could say. Not that you need to know that. So x equals 548.83 plus 203.45. We'll add these together, then round to the nearest whole number. 548.83 plus 203.45, and we get 752.28, which rounds to 752 units. All right, continuing along with page 2, some more word problems, triangles. So we have a hot air balloon rising vertically. The angle of elevation from a point on level ground 126 feet away from the balloon to a point directly under the passenger compartment changes from 16.2 to 33.5. How far to the nearest tenth of a foot does the balloon rise during this period? Okay, so we're looking for this distance right here, which this nice picture has been drawn for us. So the way that we do that is we need to do b minus a, where a is this shorter length here, and b is the entire length. So the way we find b, we look at this large triangle. That's going to be the tangent of 33.5. Tangent of 33.5 degrees equals b over 126. We can use that to solve for b. And then we'll do the same thing to solve for a, but instead it'll be tangent of the smaller angle, 16.2 degrees, equals a over 126. Multiply both sides by 126. And we get that a is 126 times the tangent of 16.2. And we get 36.61. 36.61 equals a, that many feet. And then b, we do the same thing, multiply both sides by 126. 126 is reduced to 1, and we're left with b equals 126 times tangent of 33.5 this time. So we have 83.40 equals b, and we know to the nearest tenth, so we want to round to the nearest tenth of a foot. We don't want to subtract these, so 83.40 minus 36.61 equals 46.79, which rounds to 46.8 feet. All right, some more word problems. We have the Statue of Liberty problem. We're just working our way down the page. So Statue of Liberty is approximately 305 feet tall. And we have an angle of elevation of a ship to the top of the statue is 26.9 degrees. So from the ship down here in the water, we'll call this point S. Here's our Statue of Liberty. Here's the top up here, T. So this angle of elevation, remember the angle of elevation is the angle relative to a horizontal line drawn from our point of reference. That would be an angle of elevation right here. If it happened to go down instead, that'd be an angle of depression. So angle of elevation is 26.9 degrees. This is approximately 305 feet tall. How far is the ship from the statue's base? The statue's base is right here, point B. So we want to find the distance that the ship is from the base. We'll call this D for distance. So we have this right angle right here. It's assumed to be a right angle at the base of the statue. And we solve for D. I see opposite, I see adjacent. I'm going to use tangent. Tangent of 26.9 degrees equals opposite 305 over the adjacent D. When we're solving for a variable in the denominator, we first have to get it out of there. So multiply both sides by D. Our D's reduced down to 1 on the right side. And then I have D times tangent of 36.9 equals 305. And I can simply divide by tangent 36.9 degrees on both sides to allow me to isolate D. Because these tangents cancel to 1. And I put 305 divided by the tangent of 36.9 degrees in my calculator, and we get 406.2, and to the nearest foot. So we got D equals 406.22, but to the nearest foot, we can say 406 feet away. Okay, moving right along, we've got the ramp problem at the campus library. So we have a ramp that's to be built beside the steps at the campus library. Find the angle of elevation of the 23-foot ramp to the nearest tenth of a degree if its final height is 4 feet. So I'm assuming that the ramp is 23 feet long and the height that it reaches above its starting point is 4. Admittedly, this is not the most clearly worded problem, but this is our best guess for the interpretation of it. So find the angle of elevation to the nearest tenth of a degree of this angle theta. So we're looking for this angle theta. That's the angle of elevation, because remember an angle of elevation was this thing right here that elevate the angle relative to a horizontal line from your point of reference. So that'd be this angle theta. And I see an opposite and I see a hypotenuse. We do not know what the adjacent is. We could find it, but it's unnecessary because we're looking for theta, not this angle, or not this side length. So we say sine theta, since I have opposite and hypotenuse, equals 4 over 23. 4 over 23. And then to find theta, we just take the inverse sine of both sides. So inverse sine of 4 over 23, which we want to the nearest tenth of a degree. It's 1 decimal place. We type inverse sine in our calculator of 4 over 23 and get 10.015. So 10.015 degrees. So to the nearest tenth, that would just be 10.0 degrees. 10.0 degree angle of elevation. Okay, I've got 3 more problems on this page. So we have a boat leaves the entrance to a harbor and travels 100 miles on a bearing of north 53 degrees east. Okay, every time we are dealing with a bearing problem and we're describing the motion of an object relative to a certain point using bearings, it's always a great idea to mark that point on your map that we're creating. So it's leaving a harbor, we'll call it point H. And also to make a cardinal direction center point. Cardinal direction cross, we could call it, at this point H. So we got north and south, and we got east and west here. So try to stretch these out a little bit. Okay, so we know that we've traveled 100 miles on a bearing north 53 degrees east. So we draw our cardinal directions. North 53 degrees east. That would be roughly, if we went north, that's due north. That'd be north however many degrees west. So we want north and a little past 45 degrees would be the halfway point, angular wise. 53 may be in that neighborhood. So make this a little larger so it makes a nice large triangle for us. And we know that this distance right here is 100. And this angle is 53 degrees. So the question is asking, how many miles north and how many miles east, so 2 different questions, how many miles north and how many miles east from the harbor has the boat traveled? So it's essentially asking us how far to go up, how far to go north, that'd be up, and how far to go to the right, that'd be east. So we're looking for these 2 segments. These 2 segments. So this blue one for how far we went north, and this purple or pink one for how far we went east. So we have a triangle there. We can call this little n for how far we went north, and little e for how far we've traveled east. So notice we have the hypotenuse, we have an angle, and we can simply use trig to solve for little n and little e for the miles traveled north and the miles traveled east over the course of us heading 100 miles at north 53 degrees east. So we have, remember this is opposite, adjacent, and hypotenuse relative to our 53 degree angle right here. So to find E, I can use sine, opposite over hypotenuse. So sine of 53 degrees equals E over 100, our unknown E, multiply both sides by 100. 100 is reduced on the right side. I get 100 times sine of 53 equals 79.9. And it did not specify what to round to, so we'll just round to the nearest tenth. So 79.9 miles east is E. So that's our first answer. That's how far east we traveled, or the boat traveled. And then to find n, I do the same thing, but instead use cosine this time. So cosine 53 degrees equals the adjacent side n over the hypotenuse 100. Multiply both sides by 100 to solve for n. And a little lag here. Enter this in the calculator, 100 times the cosine of 53 degrees, and we get 60.18 or 60.2. So 60.2 equals n, so that's 60.2 miles north. So those are our two answers, 60.2 miles north and 79.9 miles east for this particular bearing problem. Okay, now let's reset and take a look at the next one. So you leave your house and you run 7 miles due west, followed by 5.5 miles due north. At that time, what is your bearing from your house? Okay, so I interpret this as leaving our house. So here's our house. We'll call it H again. Kind of coincidental that it was H for harbor. This one is H for house. So we are traveling relative to our north, east, south, and west cardinal directions. We are going 7 miles due west. So we had 7 miles this way, so 7 miles this way before ending right there. So we went 7 miles that way. Then we know we went 5.5 miles north. So we go exactly 5.5 miles north before ending in this spot right here. We'll call it T for terminal, our terminal location, our final spot. So we want to find the bearing from your house, and what's implied here is to your current location. Bearing from the house to the person's current location. Okay, so when we're finding a bearing, again, we have to draw the angle, the cardinal direction cross from that starting point. So we drew this already, which was convenient. So now we just need to find this angle theta. So that angle theta, because we got to know an angle to be able to determine the bearing. So we don't have the hypotenuse, but we do have both legs. So we have the opposite leg and the adjacent leg. So to solve for theta, I can set up tangent, because I have opposite and adjacent. Tan theta equals 5.5 over 7. Solving for theta, I get inverse tangent of 5.5 over 7. Enter this in the calculator. Second tangent, 5.5 over 7. So inverse tan of 5.5 over 7, we get 38.2 degrees. Which, let's say it doesn't say in the problem, but let's say it's round to the nearest degree. So 38 degrees. So this angle right here, this theta, is 38 degrees. So if we're describing the bearing from H to T, remember, we always want to say north or south first. So we want to say north first, and then we want to go this many degrees west. So we got to figure out what this angle is. And the way we do that is by doing 90 minus 38, because we know this whole angle is 90. Subtract 38 away, we get 52. So our bearing is north 52 degrees west, if we round it to the nearest whole degree. All right, last one on page 2. So we have a jet that leaves a runway whose bearing is north 36 degrees east from the control tower. So we start at control tower T, or we'll call it C for control tower. We make our cardinal direction cross here. And we start at point C right here. And we go at north 36 degrees east. So let's make our red line here. North, that'd be 45 degrees east, so 36, maybe somewhere right there. Okay, so we go something like that. All right, so north 36 degrees east, where this is 36. So important to label our angles as we go. After flying 6 miles, so this is 6 miles, the jet turns 90 degrees and flies on a bearing of south 54 degrees east. Okay, so it's really important that when we do something like this, it's not the bearing from here, but it's the bearing from the point that he turns. We'll call this point B. So we make a new cardinal direction cross. So new cardinal direction cross. And now we know it's a turn 90 degrees east, so it's south 54 degrees east. So it's a 90-degree turn. So we know this is a right angle because it says it was a 90-degree turn, right? So that's a right angle. And it goes 7 miles, so a little farther than before. 7 miles. And we want to know what, at that time, what is the bearing of the jet from the control tower? Okay, so notice what we have so far. We have a few different pieces of information. So we want the bearing of the jet from the control tower. So we're trying to find basically we're trying to find information about these angles here. And we have enough information to find this angle theta right here. Because here's the control tower, here's the jet now. We can simply, because this is a right angle, we can simply use inverse tangent of theta to find this angle theta. So tangent theta equals 7 over 6. Then I can say theta equals inverse tangent of 7 over 6. Enter this in the calculator. I get inverse tangent of 7 over 6. I get 49.4 degrees. 49.4 degrees. So this angle theta here is 49.4. So now to get the bearing from point C, our original point, to point J over here, I just need to know that it's north this many degrees east. And that many degrees, I know both those angles, so I can just add them up. Plus 36 degrees. And I get that it's 85.4 degrees. So it is north 85.4 degrees east is the bearing from the control tower to my jet's current location. All right, that concludes section 2, page 2 of the study guide.